We are on to problem 1248. We're doing some relative velocity, relative motion problems here. And if this is the first one, I would recommend 1247 just to get your feet wet, and then this problem kind of encapsulates the more difficult parts of this part of the chapter 12. And it's pretty easy if you did well in your physics 1 class. The instant shown, cars A and B are traveling at the speeds shown if B is accelerating at 1200 kilometers per hour squared, while A maintains a constant speed. Okay, so here we have A, this blue car, with a constant speed. All right, that's key because it means it's not accelerating, tangentially. Okay, and acceleration of A. Oh, we're trying to find the velocity and acceleration of A with respect to B. So I'm going to first determine that this will be my coordinate system. Okay, X positive to the right, Y positive to going up. All right, and then we're just going to, let's just dissect the information we have. We have VA, okay, and we're given VB. Alright, so VB, let's start with that one. That one's easy because it's just going in the positive X direction. So we're just going to have 65I, right, plus 0J, right? You don't have to write 0J, I'm just doing it for you guys. And then VA, constant speed of 20 kilometers per hour, right? But it's at an angle, right? So what I want to do is make sure that I break this into the X component, or let's say the I component, and into the J component. Okay, and it's 45-degree angle, so that that makes it even easier. So we're going to have the X component of the velocity of A is going to be pointing to the left. Okay, so we're going to have minus 20 cosine 45I, and then positive 20 sine 45J. Oh my god, my dog just got here. Can't leave me alone. Alright, so now we have VA and VB. We've dissected it. Okay. And then we want to determine the acceleration of A. So that's the next thing we're going to be doing, because they're giving us a constant speed, right? But remember, we also have normal acceleration. Actually, let's just say normal acceleration is going to be v squared over rho. All right. So we want to calculate the velocity, a component of the velocity for A. Right. We're going to say it's 20 squared, the velocity or the speed, divided by the radius of curvature, which is given as 100 meters. Right, which don't forget to switch your units. So we're doing everything in kilometers per hour, and we're just going to leave it like that. So the 100 meters becomes 0.1. Okay, and we have 400 divided by 0.1, so we have 4,000 kilometers per hour squared. Okay, and so this is like the acceleration for A, and then we have B is accelerating, so we have the acceleration of B is positive 1200 kilometers per hour squared in the I direction, and again, no acceleration in the J. Okay, so remember that this is the normal acceleration of A. So now remember that normal acceleration, it's pointing into the radius of curvature. Okay, so again, we're gonna have to split this 400 kilometers per hour squared, all right, into its corresponding components, which is going to be, you know, we have our J component and then we have our I component here. All right. So now let's put acceleration of A in vector format. So it's going to be, you know, 4,000 kilometers per hour squares pointing in this direction. We want to collapse it into the I component, so it's going to be 4,000 cosine 45i, and then plus 4,000 sine 45j. Okay, remember this angle here is 45. Okay, and then we're pretty much home right there. The next, because now we just have to solve for the relative velocities. So remember, they want to do the velocity of A with respect to, determine the velocity. Oh, this one is different. The velocity of A with respect to B. So we're going to do, what is the velocity of A? What is the velocity of A with respect to B? Okay. So now we just insert our numbers here. So we're going to have minus 20 cosine 45 I plus 20 sine 45 j. Remember, the b goes to this side, so minus VB 65I equals, actually let's just write it on the left hand side over here. This will be V, what's the velocity of A with respect to B? Okay, so when we, you know, when you complete this, we should have a negative I. So we should have minus 79.14 I and a positive J. Positive 14.14 J. Okay? So that's the first part of this problem. Right here. And remember, the tricky part of this problem is the crux of the problem. The crux is like the, you know, the hard part. The part you have to get over to complete it. If you do any climbing, you might have heard, oh, where's the crux? What's the crux? Anyways, the crux of it is identifying this over here. That you're dealing with some curvy linear motion. The car is going around the corner, so you have to break down the normal component of the acceleration. Okay, because remember, it's not accelerating in this direction, the tangential direction. It's only accelerating in the normal direction. So now we do, what is the acceleration of A with respect to B? What is acceleration of A with respect to B? Remember that notation. With respect to is always in the bottom, right? And yeah, so what do we want to do? We want to plug in all these values here. This values and these values. So we're going to have acceleration of A with respect to B is equal to, it's acceleration of A minus, so it's this term minus the B term. So we're going to do, where is our A term? Right here. So we're going to do 4,000 cosine 45I plus 4,000 sine 45j minus AB, so minus this term, okay, 1200I. Okay, yeah, 1200I, and when you complete this, hopefully I have it down here. So I did it in a calculator. I hate when I do these videos and then I completely forgot to bring the calculator. then I'm just like, oi, what do I do? So minus 16, 28, no, sorry, 16, 28.43. And yeah, a lot of times when I do these problems, I do it all in one go. I don't really prep for them. I just do them. So, however I am going through them, that's how my mind is working. Yeah, so that's why you might see some tiny mistakes here and there, just because I don't wing them, but I just do them, just from so much experience. It's funny because like after tutoring for so many years, you learn how professors just know the book without even having to look at the book. That's kind of where I was. Next level, man, next level. Alright, so this is the result. You get 1628.43i minus 2828.43j. Okay, and that's the acceleration of A with respect to B. Okay, remember, just if you've been watching these videos from like, you know, the statics videos, I always, what are they giving us? Break it down to vectors, because you're going to be dealing with vectors for the rest of your classes. You might as well just get used to dealing with just writing everything in vector format. So yeah, so write everything in vectors, dissect the problem as much as possible, and then begin to work on it. And always in the back of your mind in dynamics, you're always, if you see any curvatures, you're always thinking, oh, I might have to use this formula, or you know, that crazy one that we did from like 10 problems ago where it was like the second derivative of y with respect to x and so on to find the radius of curvature. In this case, they gave it to us. But yeah, don't want to confuse you guys. Anyways, that is this last problem. Hope this video helped. You know, my goal is just to help you guys get the confidence to know how to set up your problems. And yeah, if you guys found this helpful, give it a like. If you have any questions, comments, just comment down below. Really appreciate your time, guys. Take it easy.